The multiverse is one of the most fascinating and controversial ideas in modern physics. It is the idea that our universe, with all its stars, planets and galaxies, might be just one of many, if not infinite universes. Each of these other universes could have different physical laws and constants. There could even be countless different versions of you in each universe. It's an idea that some of the most famous and influential physicists of our time support. But there's just one small problem. There isn't a shred of evidence that these other universes actually exist. Let's start by looking at where the idea of the multiverse comes from. Scientists have proposed the multiverse in several different ways. One idea comes from string theory, a complex theory that tries to explain everything in the universe by thinking of particles as tiny vibrating strings. String theory suggests that there could be many different ways these strings can vibrate, leading to the idea of the landscape of string theory, where there are many possible configurations of strings that could correspond to different universes with their own unique properties. It's important to note that string theory also lacks empirical evidence, so scientists may be trying to explain something that isn't true, string theory, with something else that isn't true, the multiverse theory. Another idea comes from the many worlds interpretation of quantum mechanics. In the many worlds interpretation, every possible outcome of a quantum event actually occurs in a separate branch of the universe. This means that when a quantum event happens, the universe splits into multiple branches, each corresponding to a different outcome. In this view, there is no collapse of the wave function. On the other hand, the Copenhagen interpretation of quantum mechanics, which is another widely discussed interpretation, suggests that particles exist in a state of probability until they are measured, at which point the wave function collapses and the particle takes on a definite state. This collapse is often associated with the act of observation or measurement by a conscious observer. The many worlds interpretation and the Copenhagen interpretation are contrasting ideas, but in the context of the current state of scientific understanding, there is more experimental evidence supporting the phenomenon of wave function collapse, as described by the Copenhagen interpretation, than there is for the existence of multiple universes as described by the multiverse hypothesis. The double-slit experiment and the Copenhagen interpretation. This interpretation is simpler and more straightforward because it doesn't require the existence of multiple universes. It also aligns with the experimental results without making additional assumptions. The Copenhagen interpretation has strong experimental support because it matches the outcomes observed in experiments, such as the collapse of the wave function when a measurement is made. Finally, there's the concept of cosmological inflation, which suggests that right after the Big Bang, the universe expanded incredibly fast, possibly creating many separate bubble universes. However, all these ideas share one problem. We can't see or interact with these other universes. In science, for something to be considered a strong theory, we need to be able to test it and see if it's true or false. But if these other universes are completely separate from ours, there's no way for us to observe them or get any information from them. This makes the multiverse idea very hard to prove. Good science relies on evidence and the ability to test ideas. For example, we believe in gravity because we can see and measure its effects everywhere. The multiverse theory, on the other hand, doesn't give us anything we can directly observe or measure. It's based on complex math and theories that go beyond what we can see and test. Occam's razor is a principle in science and philosophy that suggests the simplest explanation is usually the best. In the context of the debate about the existence of multiple universes, Occam's razor would suggest that if there is no direct empirical evidence for the multiverse hypothesis, it may be simpler to stick with explanations that are supported by current evidence, such as the Copenhagen interpretation of quantum mechanics. This doesn't mean that the multiverse hypothesis is necessarily wrong, but it does caution against accepting complex explanations without strong empirical support. Some scientists think the multiverse helps explain why our universe seems so perfectly set up for life. They argue that if there are countless universes, each with different settings, it makes sense that at least one would have the right conditions for life. This is a way for them to explain the highly unlikeliness of a fine-tuned universe without admitting the likelihood of some sort of intelligent designer to finely tune it. Having a fine-tuned universe without an intelligent designer is about as likely as having a perfectly tuned instrument without having someone to have tuned it in such a way. Without the multiverse, scientists would have to admit this fact which would completely contradict most of their physicalist worldviews. There have been attempts to find indirect evidence of the multiverse. For example, some scientists have looked for signs of collisions between our universe and other universes in the cosmic microwave background, which is the afterglow of the Big Bang. So far, these searches haven't found anything convincing. Critics of the multiverse theory worry that it might lead to lazy science. If we can just say, "It happens in another universe" to explain anything we don't understand, it stops us from looking for real answers that we can test and prove. Science works best when we can make clear predictions and test them, not when we rely on ideas that can never be proven wrong. The idea of the multiverse is popular because it tries to answer big questions about the universe that we don't fully understand yet. But without evidence, it's more of a fun idea to think about than a scientific fact we can rely on. In the end, the lack of evidence for the multiverse reminds us to be careful about separating what we can prove from what we can imagine. The multiverse theory is a great topic for discussion and imagination, but until we find real evidence, it stays in the realm of speculation rather than solid science. While the idea of multiple universes is intriguing and sparks lots of interesting conversations, remember that in science, we need evidence to back up our ideas. For now, the multiverse remains an exciting yet unproven concept, with no real evidence to show that other versions of yourself or other universes actually exist.